Before you begin Introduction to Molecules, make sure you carefully read the overview, objectives, background materials, safety, and preparation. That will help you get through activities 1, 2, 3, and 4 more easily. The directions for activity 1 begin on page 6 with instructions on how to write Lewis dot structures. And in general, these instructions are very similar to what we've gone over in class and in your textbook. The first step is to determine the number of valence electrons of the atoms in the chemical formula, sum those valence electrons, determine which atom is to be the central atom, and place that central atom in the middle. The guidelines differ in that there's an intermediate step where you identify the valence electrons as dots around each atom. So oxygen has 6 valence electrons, there are 6 dots around it, and then silicon has 4 dots around it because there are 4 valence electrons. Then they take a minute to determine the total number of electrons required when the Lewis dot structure is finished, and in general that's going to be 8 valence electrons. The exceptions are hydrogen can only accept 2 electrons, boron only needs 6, and beryllium only needs 4. Then they have you create a skeletal structure by moving these dots around. You do not have to do that. You can just draw your Lewis dot structure according to the way we've gone over in lab. They do address the issue that sometimes 2 different Lewis dot structures can be drawn that both satisfy the octet rule. For example, silicon dioxide is their example, and you can draw silicon dioxide with 2 double bonds or with a triple bond and a single bond. You don't really need to calculate the formal charge as they have written here in this guideline. Instead, you can choose the Lewis dot structure that is more symmetrical. That will work for our level. So the Lewis dot structure that has 2 double bonds is more symmetric than the one that has a triple bond and a single bond. However, as long as you follow the rules for achieving the octet rule and identifying the elements that have exceptions to the octet rule, as long as your Lewis dot structure follows those rules, it will be considered correct when I grade it. So back on page 6, it tells us the molecules to be used in activity 1, 3, and 4 are found on page 22. So let's take a look at page 22. So data table 1 has 3 different sections according to the activity. So activity 1, 3, and 4 will all use the same molecules. You are to choose 3 compounds in group 1, 3 compounds in group 2, and 3 compounds in group 3. These are the compounds you'll use for activity 1, 3, and 4. So they ask you to make copies of this data table for activity 1, chemical formula, dot diagram, electrons, central atom, and Lewis dot structure. And I've actually made a table for you. You can access this table in Canvas either as a Word document or a PDF. And for activity 1, here it is. And I've given you an example. So a chemical formula, I've chosen a chemical formula that is not in any of those groups. And then the dot diagram just means putting the central atom in the middle and then putting the valence electrons as dots around each atom. So oxygen and sulfur all have 6 valence electrons, so there's 6 dots around each atom. Then electrons means the electrons needed. And oxygen needs 8 valence electrons, sulfur needs 8 valence electrons to fulfill the octet rule. Identify the central atom, and then draw the Lewis dot structure. And you can draw that Lewis dot structure in whichever way you like. And then you'll be doing that for the 9 compounds, 3 in group 1, 3 in group 2, and 3 in group 3.